Hello everyone. My name is Saurabh Nayak, and I welcome you all to the second video of our uh, deep learning playlist. In this video, I'm going to explain some of the concepts that are very basic to the deep learning, but that are very important in order to understand the complex networks and complex frameworks of deep learning, such as neural networks, multi-layer perceptrons, and other stuff. So, what we are going to see in this video is just a basic perceptron model. Second one is we are going to play with that perceptron model with the help of an example. Also, we are going to see how this model, the perceptron model, is a little bit, not you can say significant, but little bit inspired from the nature. And last one is we are uh, going to be started with the multi-layer perceptron. Here, I'm going to give you the just brief information about MLP. We are not going to delve into deep into MLP in this lecture. So, as you know, like in previous video, we have like seen a McLaughlin-Pitts neuron that look like this. So this was the first time that some of the mathematicians and some of the computer scientists have like derived their equations or derived their models from this basic uh, McLaughlin-Pitts neuron. So you know that this is very important. So you are not, if you are not check out this video, you can check this video is in the playlist, and I will mention the link below in the description. So now the perceptron, which is the base for our deep learning playlist or deep learning architecture or framework. You can say interchangeably framework and architecture. We can use these words. Okay. So now, so the perceptron. So we can just take a look at this image. So we can see here are some inputs, and this neuron is giving some outputs. And then look at the perceptron model. You can find many similarities between that model and this model. So first of all, there is the same concept of inputs that we take inputs from left side x1, x2 up to xm. It depends on your data. We feed that information. The information may be in the form of numbers, maybe in the form of pixels of image. Their inputs can be anything. Each input is associated with one of the weights. So x1 is associated with w1, x2 is associated with w2. That similar way, xm is associated with wn. So one of the you can see one of the new part, or we can say one of the new feature that the perceptron model includes is the one bias. So in previous models, we can't, like, they don't have any bias term. So we are going to look deeper into the what is bias, but basically you can just ignore the bias right now. We are going to see what bias is and how it works to generalize the neural network in the future videos. And so here is the x0. These are the inputs. Okay. So if you are wondering what are these W0, W1, W2, Wn, so these are the weights. So what are the weights? Weights. So each input has weights, and these are like score for the importance of these features. So let's say we have x1. How important is that feature? It will be depends on the W1. X2. How important is the feature? It depends on the W2. For example, let's say if you have one input as house. Let's say we are going to predict the house price prediction, which is one of the basic problem statement in machine learning. So let's say our first input is house. How many rooms are there in one house? So let's say there are four rooms. Another is what is the carpet area of that house. So these depending on these inputs, the W1 and W2 means weights are going to be trained, and they are going to be updated every each time when we train our network. So we are going to look into that, how the training goes and how these weights gets updated. So essentially, just you can see these weights as the score for its importance of its uh, inputs. So and uh, this is the equation where we just calculate the weighted sum of the inputs and weights. So we multiply x1 with w1, we multiply x2 with w2, we multiply xm with wm, and then we add this together to get one of the outputs of this module. So this module is then also called as summation block. So as from the name you can guess, it just adds the things. And then this model provides the input to this model. So what is this model? So this model is called as activation function. This is one of the mathematical function which has a task. The task is to get the output in the given range, or let's say after multiplying weights and inputs. If sometimes what happens is there are very big numbers in inputs or weights, so we can't like computer can't handle these kind of big numbers like 1 million, 1 billion. So uh, uh, we need to like get those number into a specific range. So we use the different activation functions. We are also going to see how the functions help us uh, to put some numbers into the specific range. We are going to see how mathematics behind the activation functions work. But basically, you can think it as it just quizzes the number to the specific range. The specific range can be between 0 to 1 or -1 to 1, or there are different functions which we can activation functions we can use. There are some examples like ReLU. Currently, if you are looking at this activation function is called a step function. So if our input is positive, then it outputs one, and if our input is less than zero or negative, it outputs zero. So it is one of the first basic activation function. There are different, as I said, there are different activation functions which we use for more complex structures and more complex model fittings. So now we are going to see one of the example with the help of perceptron. It will help you to get better understanding of how perceptron model works. So for the example, we are going to take one of the data set. So uh, data set contain two features. First one is GRE, second is CGPA. So if you don't know, GRE is an exam. So I think it is out of 340 marks. So this guy has gotten 310 marks out of 340. And CGPA is, you know, the CGPA. And here there is one independent parameter called admit. So what is said that whether this student with the GRE score and this CGPA got admission to one of the university. So this is an very arbitrary data. So this is not a real data. So just for the sake of the example, uh, we are going to take this example. So let's start with the example. Okay, so this is perceptron as you have seen in the previous slides. I have just hand drawn the example. My drawing is very bad, and I also don't have the pen and pad, so I have drawn it from the mouse. So forgive me for that. But yeah, you can get it like x1, x2 are the inputs. What are the inputs? So these GRE and CGPA, these are the inputs for our model. So x1 and x2 are these inputs. So right now, just ignore the bias. So we are setting bias to 1. We are going to explain what is bias and how it helps in future videos. And now, so W1 and W2. So as I said earlier, this W1 and W2 are like scores for the inputs, like which input is very important, and it gets updated every time we train our neural network. So for the currently we don't know how neural networks get trained and how these get updated. So we are going to statically assign some value to the W1 and W2 for the sake of understanding. Okay, now we are going to look at how neural network uh, after training evaluates its data or inputs. So for this context, you can assume that we have already trained a neural network and we have some input to give and to test the neural network, and we have some weights uh, for the training that we have for the testing that we have achieved from the training. So this is W1, this is W2, and as I said earlier, we are going to set bias to the 1, and we know that we just multiply W1 with x1, W2 with x2, and we just add all these things together. Uh, we sum all these things. So let's do that math. So 310 into W1 weight 1 plus 9.0 into 2 plus the bias term that is 1. So we obtained 329. So what we are going to do with this 329? So we are going to pass it to the activation function. As we said, as we have seen earlier, yeah, this activation function. We have achieved this z from the from computing x1 into w1, x2 into w2, and plus bias, and then we are going to pass this into the activation function. So for this example, we have defined a simple activation function, which is this. So our function is like that. If our x, that is the output we got from our previous module, is if x is less than 300, then we are going to output it as 0. So 0 means not admit. And if our output from the previous module is greater than 310, that we are going to output it as 1. So representing it got admitted. So as we know that our previous module has outputted 329, so we are going to pass this value to this function, and the output that we get is 1. So just like that, the neuron or the perceptron works. Now this is very simple example, and these values of W1 and W2 are taken arbitrarily. So this can be very small or this can be very big. So depending on the context, this value can change. So just to get a basic idea, I have explained with one example. So as I'm saying that now new perceptron or the different deep learning models are inspired from the nature. So what do we mean by inspired from nature? So take a look and to, look it into this image. So this is one of the neurons that we have in our nervous system. So our nervous system is like collection of billions of these neurons. They are connected with each other. They just passes some electric current from one neuron to another neuron. So these are called as dendrites. And if you look at the neuron in our brain and the model, that perceptron model that we have looked at some time before, we can see there are some of the similarities. Like it also takes input. These dendrites are also used for the input. So yeah, we can see there are some of the similarities. They are not quite similar, but they are significantly similar to the neuron that we have in the brain. So now the multilayer perceptron, the main hero of our story. So why we need multi-layer perceptron? So basically, first of all, let me learn what is multi-layer perceptron. We have neurons, the perceptrons. These are the single perceptrons that we have looked at this few slides before. So we just tag them into one another and connect them with each other. So after connecting them each other, they generate some structure. We call that structure as multi-layer perceptron. So why we need multiple perceptron? Instead, we can just if we can just use one perceptron, then why we need multiple perceptrons or multiple nodes? So the reason is the complexity. So in real world, the data that the data set I just showed you is not that simple. So the real data sets are a bit complex, and so in order to achieve the best result out of these data sets, we need a strong and robust model to adapt to these data sets. So we are going to see how these neural networks are going to adapt to the different data sets or the different data points in the future video. Just keep in mind that we use multiple neurons in order to just to get a strong network that can generalize better to the unseen data. So you can uh, see on Google or some of the books how the neural network generalizes the data, or how the mathematical model of the MLP is going to update uh, the weights that we have seen W1, W2, how we are going to, and we also are going to see how backtracking, which is the algorithm for updating the weights of the neural networks. So we are going to see in the future videos, but you can also check that things into different books or the YouTube videos, or just one simple Google search. So that's it for today's video. In next video, I'm going to go deeper into the this network, that is the MLP, and why we use these networks and how the training happens. So thank you.